All right, good afternoon, everybody. From New York City, we sit today. We thank you very much for attending this webinar. On behalf of everybody, Team Appranix, this is we say thank you. This is a very, very well attended webinar, not just all 3 time zones in the US, but we have some good folks from the other side of the pond joining us. So good morning, good afternoon, good evening to all. I'm going to keep this short and sweet, so to speak, due to time and respect of your time, and we have a lot to get to. And again, thank you for joining our Google Cloud Outage webinar showing why cloud application resilience is important with Appranix and our solution and what we deliver. This webinar will also be available no later than EOD tomorrow on YouTube, and you can also head over to YouTube and just search Appranix, and we have several other webinars that are available for your viewing pleasure, so to speak. Please, during the course of the webinar, feel free to shoot over your questions, and we will provide you with high-level answers probably towards the end of the webinar. We will save time for Q&A, but during the course of the webinar, feel free to launch your questions in the box provided. We really appreciate that. So on behalf of Appranix, again, thank you. I'm going to turn this over to our co-founder, our CEO, Govind Rangasamy, and he will take you through a high-level, granular level, along with the demo at the end of, probably at the half-hour point. It'll take you through our full high-level view and granular level nature of our backup and recovery application-centric solution here at Appranix. So with no further ado, let me turn this over to Govind.
Yeah, Mike, thank you very much. Gentlemen, thank you for joining again. So let's get started. So what we are going to talk today is about application resiliency, and under that capability, you will see why backup industry overall is changing, why disaster recovery industry is changing overall when you move to the cloud. And the topic of the webinar today happens to be, there are a lot of outages that are happening, not only Google side, but across all the major hypercloud platform providers. AWS has gone through multiple of them, but that's not the point here. As the platform providers say, yes, there will be outages because it's a regular data center. Of course, it's very sophisticated, and a ton of applications run there, millions of servers run there, so it's complicated. So it's these type of outages are bound to happen. But on the other hand, the platform providers also say you've got to properly architect your application as well. So having gone through multiples of these webinars where we talk about well architectures on top of the cloud platforms, cloud application resiliency is one of the solutions that you could utilize right off the bat that is completely built cloud natively on this platform. So today we'll focus on Google Cloud, and by the way, the solution is available on the AWS and other cloud providers as well. So Appranix is an industry-first cloud application resilience. So let me stop there because there is a notion of cloud application resiliency that is a topic that is new, and the notion of industry first. It's not industry first from a backup and recovery perspective, but cloud application resiliency perspective. But at the end of the day, it's all about providing the capabilities to back up and recover the entire solution from an application and application environment point of view. So let's start with a view of what's happening in the market today. Cloud enabled or cloud native is the modern application model. When we talk about cloud enabled solutions, these are the applications and the infrastructure, or even some of the organization closing down the entire data center as well and lifting and shifting those applications over to the hypercloud platforms like AWS and Google. And when they lift and shift, they not only lift and shift the virtual machines and the data associated with it, they are laying down the entire new network topology using all the cloud native networking tools, new security posture, and entire capabilities around an application from an application environment point of view is being created from scratch, right? The entry point being the application, and the first unit of discussion is virtual machines. But at the end of the day, it is the entire application environment that really matters. So after these applications are cloud enabled with all the cloud native services and the infrastructure, you now have to rethink about some of the services that you provide to your application developers as well as your organization from a business resilience perspective. And all these cloud providers provide resilient global infrastructure because it's a unified data center architecture. It's not like you have 5 different storage vendors providing 10 different tools in terms of storing the data. It's one storage system, right? On the other hand, modern cloud applications are being built using containers and Kubernetes because when you start thinking of something completely new, you don't want to worry about the packaging aspect with respect to all the libraries and everything together, and also from infrastructure utilization point of view, containers make sense. So the benefits of the containers are very well understood, and the orchestration of those containers when the containers are in thousands or even hundreds for that matter, when they are used for microservices, Kubernetes is the default platform, and Kubernetes as a service is available from Google or from all of these providers. So both scenarios, and in fact, if you stretch it a little bit, there could be applications that utilize both the container aspects running on Kubernetes for front end of the applications where the stateless components run, and all the back end of the applications and platforms that run using the traditional compute instances, virtual machines, and so on. So in those situations, what do you do from a backup and recovery perspective, right? That's a minimum thing that you could think of for providing resiliency for the applications. So, when you think about resiliency, why do people really look for resiliency? And if you think about disruptions could come from anywhere. It could come from a single bad deployment of an application component, not even the entire application, just a single application component. Along with it, there could be changes in the configuration of the cloud, because when you move from data center over to the cloud, you are practically changing your operations model. You are becoming DevOps oriented culture in the organization to operate your infrastructure, because you don't want to go back and look at individual component automation. Even if you try to do, it's all infrastructure as a code. So a single bad deployment could bring down the entire thing. Individual cloud service failures could introduce disruption to your applications, right? It is not the entire region of the failure, but there could be network issues. The VPC could be down. That's like a very rare incident. But what if your cloud DNS is down? What if your part of the compute instances are down? Not necessarily the entire East Coast region, but within a zone, some racks are down because of which a few of the customers are affected. It could be you, or it could be just the entire East Coast as well. Sometimes. So individual service failures could introduce those disruptions as well. And this is not the least. In fact, I have a slide completely dedicated on the ransomware attack. What's happening from a market perspective. It's a huge one. Ransomware attacks are massive nowadays. And last but not the least, entire cloud region could fail. This is a bad event, but it could happen as well. So in these situations, as a site reliability engineer or a cloud operations person who is responsible for the resiliency of the application, you will have to ask, can I at least back up and test my recoveries quick to become compliant? So I want to become compliant to begin with. right? So backup becomes the foundation operations block that you would offer to your organization if you're managing in a shared infrastructure perspective. If you're carrying over that application infrastructure over to the cloud, how do you set up that basic backup capabilities, right? So let's start from there and then look at from entire application environment perspective. Talking about ransomware attacks or overall cyber attacks perspective, the numbers are out there. Just wanted to highlight some of the top level news items that pop up all the time. This could be changing like as we speak right at this particular moment. But overall, what Forrester and Gartner are saying is this is real, right? It's going to be like $11 billion in the coming year. You can put any number that you want, but you don't want to be the one that's going to be affected, right? You don't want any of this thing to happen. But in the case of one of those attacks, you've got to be prepared. So in a backup at a minimum cost is the starting point for any of these. And then you can go from there in terms of providing the entire application resiliency. Given that there is a well understood cloud shared responsibility model, because the operating model changes. It's not like the organizations create their own data center or even the co-location data center, and they need to operate the infrastructure, ping, power, and everything that they need to create and manage and maintain. That particular problem has gone away when you move to the cloud. In fact, some of the higher level problems or the services provided by the cloud is well understood now. It's not like 10 years ago. Service security is taken care of by the provider. API and console access SLAs are 99.5%. So most of the time you have all of the time, if the region is alive and well, you don't have any problem logging into the service and service console and making changes, or even through the API. But on the other hand, customers are responsible for a variety of operational issues with respect to application availability, security, and implementation. Right? This is also well understood, and the cloud providers continue to kind of educate in this area more and more. Hey, yes, we provide the capabilities with respect to the storage and storage availability and so on, but with respect to backup, it's your responsibility. We provide the nuts and bolts of it, but you'll have to make the car and run, right? So we'll talk about resiliency day in, day out. Now, from an Appranix perspective, and from this particular webinar perspective, we'll talk about how you can achieve that resiliency when any of the disruptions happen. So let's start from a backup and go from there. Typically, when you move your application over to the cloud, right? When lift and shift and you moved, great, thank you. And you're running on top of the cloud platforms. And now the next thing, even before moving, you would have built some kind of landing zone during the conversation. What are we supposed to do with respect to backup? The typical scenario is that, if I'm running one of the legacy backup solutions that has all the agents and stuff like that, I would also move the backup solution because cloud is anyway a target. A lot of backup companies are backing up to the cloud, but the application itself is running on the cloud. So, why don't we utilize the cloud itself as the ultimate target? You don't have to even move the data, so it should be faster. So this is where a lot of these companies waste too much on the cloud. In fact, there is quantification around it. More than 30% of the cloud spend goes to the legacy backup and recovery if you move your legacy backup solutions over to the cloud, right? Because you need to now put the agent on top of that and you have to manage. And I will show a little more complicated picture, if you will, in terms of complexity. It's too complex as well, right? You have to put, if there are 1,000 virtual machines that you'll have to manage across multiple applications, then you'll have to put all those agents and manage them, right? And think about, recovery perspective, the operating model has changed using infrastructure as code. That is like a mandatory approach for operations because it's consistent, it's codified, you can change, you can go back, all of the good things that happen with infrastructure as code if you want to recover. So why back up if you cannot recover? Because a lot of these backup companies, talk legacy ones, you talk about backing up, but how many times you recover? You've got to be able to recover if something were to happen, any type of disruption to happen. On the other hand, most of the time, you cover only, rough calculations by about 12% of your application environment. So when we talk about application environment, we'll go down deeper in this area. 12% of it, meaning that virtual machines, so file systems and databases. But what about the entire application environment that is made up of all the networking, all the firewalls, all the securities of it, right? All the load balance, all of that has to be taken into account. Unless you cover the entire application environment, you cannot really bring back the application, and you don't get the application resiliency. It's not about infrastructure, backup, recovery, and so on. It's about application resiliency. All of that nuts and bolts of how you back up and how you recover, all of that should be taken care of. And that situation really works even if you got attacked by ransomware or any other attacks for that matter. You have a copy of that entire application environment, your data, your configurations, your services that you could bring up to at least borrow time to go back and recover your production environment. So that is the key thing that we would like to solve. So there are ways to create it. There are people who kind of would love to go in and put together the coding. It's all codable. Infrastructure as code is the beginning part of it, and the versioning of that is such an important thing. So you have your public cloud infrastructure, and you have your cloud application environments that are running. In this particular case, we chose Google, and the demo will be focused around Google as well. But if you think about why we talk about that application resilience in the nightmare situation, is because you start with complex backup and recovery infrastructure, right? You buy the backup product, you will have to run the backup product in a highly available manner. So you tend to put that backup manager and highly operating it with a bunch of instances for the backup manager in one of the regions. What if that region gets affected, right? Then what happens to the backup manager? You will have to provide the backup as a service to your internal organization. So which means that you hold the SLA responsibility for that because it is backup, right? And now you will have to put in all the agents on the backup systems one by one. The versions of the backup agents need to be properly managed, updated, maintained. And then you will have to really think about large scale data footprints as well. So how do you really kind of manage large data sets behind those applications? So, and the storage lifecycle management if you are codifying it. And then you will have to do it yourself, infrastructure as code. Now you have to really think about, from a Google Cloud perspective, you'll have to think about deployment manager, cloud service management. And then if you're bringing in the DR configurations, then you'll have to really think about the storage replication is different from the backup, right? You buy the backup products, and then you buy the DR product that's most likely associated with the storage replication. Then you're replicating over through the agent or some other mechanism. All of that, I just added the entire coverage here. You only cover 12% of the application environment coverage. And don't forget that you are making that network congestion due to backup jobs. So you're going back and, whenever you run the policy, you'll have to think about the everyday hassle of, production environments getting affected because you are using the cloud network that is supposed to be dedicated for your production network. Unless you put in a second NIC, and then you will have to manage, then you will have to really think about, dedicating that network for the backup traffic, which you would have properly done in the data center days. Now, if you are on the cloud side, you will have to figure out, even the network cards are different, right? So you have to think about all of that. What happens to the network congestion? And all of that, what happens is that you are taking the backup manager, and the backup manager is actually utilizing the storage from the same cloud. So you're pulling the data out of the virtual machines that are running in the same region of the cloud, and then working so hard to pull through your agents through the network congestion, and then putting it back on the storage system somewhere that's managed again by the cloud provider. Does it make sense, right? In these situations, when you say, are your applications really protected? Maybe with all the complications, when you have only 12% coverage is there. So we simplified it. That's what we did. We simplified it, made it a SaaS. And 1, 2, 3 is all is required at the end of the day. So it's easier to see and subscribe how the entire thing runs, right? So if you think about it, you subscribe, you can go to AWS Marketplace or GCP Marketplace. In this particular, we'll talk about GCP Marketplace. Subscribe to Appranix. You can auto discover your cloud application infrastructure as a whole. And then you add the policy, just, typical backup policy. It could be 15 minutes policy, 30 minutes policy, an hourly policy, weekly, daily, monthly, and yearly. Combine all of them together. It's a backup environment. So when we do that, you not only cover the virtual machines and the databases and so on, but the entire application environment. That includes all the security groups, all the policies associated with them, all the configurations, all of that. We call it as application environment time machine, right? To simplify all of this, you can go back in time. And then with a single click, literally, maybe one more click because you will have to type in recover, you can bring back the entire environment at any particular point in time. So we'll demonstrate it. We are not just going to put this. So achieving resiliency is the core of our mission. Appranix provides that site reliability through true cloud application resiliency. And that is provided as a SaaS service to you guys and at a higher SLA than what you could run, because our own system manages our own service, which is highly available with multiple region protection. And not only are we running on our own system, but large enterprises are talking about 300 plus terabyte of data infrastructure with 354 virtual machines running hundreds and hundreds of applications. We're talking about 21 petabyte copy data with 50,000, 56,000 to be exact, snapshots and multiple VPCs, you name it. That is the size of the environment that's managed by Appranix today. It's huge. And companies like Oslo Luxottica, where if you're wearing one of those fancy iframes, it's all made by Luxottica, and then you have the lenses from them. They are one of our customers, and they've been running Appranix for more than 2 years now. So smaller companies and the larger companies, smaller companies like Prague is an edtech company. They've been running on Google platform and utilizing our system for a number of years now. So at the end of the day, it's about application resiliency. The way we do it is that under the hood, start with Appranix SaaS, you give the read-only permission. We do not affect the production environment, but you can pretty much read the configuration of the data. That's it. Nothing else. Everything else, your data, your keys belong to you, which stays within your environment. It doesn't move. We capture the entire application environment. We build the application environment time machine. The system continues to learn whenever your configuration changes. It will continue to learn because every time we capture, something would have changed through API, through CLI, through console, through any number of mechanisms. Your environment would have changed. So we need to make sure that that entire environment is appropriately synced up with the data that you capture for backup. So you got to create an incrementable model where you can go back in time, which means that now you'll have to think about what is that version of the infrastructure as code that corresponds to a particular version of the snapshot of the application that is spread across multiple virtual machines. So if you think about 56,000 snapshots that are captured, now how do you know which snapshot aligns with which particular image of the virtual machine corresponding to which particular version of the application? And in that, you will have to think about what is that security group that was supposed to be in there? Is it still there? Or was it like deleted at some point in time? How do I go back? If you delete the security group, by the way, you have to remember all the configurations, and then you have to attach it to the right instances, right? There's another set of problems with security groups that it's not highlighted in a lot of places, but that deletion happens as well. So all of this right? How do you really bring up? When you bring up that entire environment, it looks like this. In a very simple 5 virtual machine instance, in this particular case, you can see the connections and dependencies that need to be properly calculated based on your application at that particular point in time. And also, you will have to make sure that the ordering of that application environment needs to be proper as well. So you cannot bring up an instance first that is not supposed to be brought up first. In fact, it's the third one that is supposed to be brought up. How do you figure that out? And what are the DHCP options between those instances? When you connect with the load balancer, what happens? Is it supposed to be connected 1, 2, 3? You know, what type of load balancer configuration when you bring up that instance? All the VPC configurations need to be cloned as well at that particular point in time. So it becomes complicated every day. And not only that, if you are a DevOps oriented company, it's a culture change, but you made the change. That's a difficult one to change. But if you did that, then you will have to build in that capability for the resiliency as well. So you can actually achieve continuous resilience by including a single line of code in your pipeline that will automatically take the copies, integrate it into your pipeline. That way you don't have to worry about it. You just insert it once, you will put the policies, and that's it. It will make the copies, automatically manage the copies wherever you want it to configure, so that you can go back and recover at any particular point in time. So that could happen within the same region, between 2 zones. In fact, there are 3 zones with AWS in one of the regions, because you need to have zone level protection as well. So you can have level 1 resiliency, we call it, and level 2 resiliency in some cases, where you'll have to protect much beyond that region. Most of these financial institutions, insurance companies, in fact, manufacturing companies, they don't want to even keep the data within their own account, because if the ransomware comes in, it penetrates through all kinds of different layers to get into your account. So you want to actually keep the data completely in a different account in another region, protected over a period of time, so that you can go back into it, right? That account could be even managed by a managed service provider. That's an easy, it's a handoff. So that way you have a single throat to choke on top of the cloud provider as well. So you made the decision to go to a particular cloud. That itself is hard in terms of training the organization and making sure everything runs. So you invite managed service providers, and the managed service providers actually take care of. That's a great service that they offer. But now, you have the responsibility to kind of recover the data when something bad happens, any disruptions happen. So you can have a nice split of responsibility by handing over the entire data. You can have the data in your own kind of environment in the local region, local zone, but the remote could be handed over to your managed service provider. In the case of containers, you might want to even think about secondary cloud provider, because you pulling the data completely out of a primary cloud provider is really hard enough. But if you're running containers and Kubernetes, you have a solution to bring up that front end of the application in another cloud itself, for that matter, right? So overall, you can use the solution for multiple purposes. I don't want to go over every one of them, but there are multiple use cases that you can go after. With backup and recovery cloud native way for the entire application environment at 1/10 of the cost. So if you think about it, Appranix delivers value on day 1. There are no more hassles of putting the agents. 1/10 of the legacy backup and disaster recovery cost, because we are pretty much leveraging all the wonderful capabilities that are built into the cloud itself. It becomes so easy, becomes so fast. Your RPUs are now achievable even for the largest data infrastructures. And Appranix reduces the risk by protecting 100% of the entire environment, cloud application environment, not 12% of it. And Appranix further reduces the risk by removing all the complexity that I talked about in terms of dependency management, in terms of creating the configurations, infrastructure as code, all of that completely removed as well, right? So given that, the TCO ROI is a no-brainer, and you can kickstart anytime by going to the AWS or on GCP. If you're in GCP, within the console built into the system, so you can pretty much subscribe and you are in permissions wise. And there are 14-day trial period. You don't have to pay anything except your own storage costs that you want to experiment with. You can always delete that instance. So given that, let's jump onto the demo. Mike is monitoring the question and answers box. You could type in the questions that you want to want to be answered at the end of the webinar. So let's start with a very simple application, and that application is OpenEMR. It's an open source application for emergency medical records. Well-known application in some areas. So it's a distributed application. It has a bunch of database components and the front ends that are running, and this application runs on the Google cloud infrastructure on the central region of GCP. You can see it's MariaDB in the backend. It's a MySQL compatible one. So let's connect to the Google console as well, just to make sure that when I change the DNS, it automatically comes up appropriately. And this application runs here as I see. And there are multiple consoles. I will switch back and forth just to make sure that it's properly explained. So you have the operations part. I can see all the operations that are being triggered and managed by Appranix, just to make sure that you capture that. And the backend snapshots, you can see this is one of the crucial ones that I want you to understand what happens with respect to your storage, because there is a cost element associated with the storage component. So if you take a 10 gig disk size, the first copy is 10 gigs, you're copying that entire thing, but incrementally right after that, right, there are incremental copies that are being made that are only very limited in size. So it's not like sometimes the application might not have even changed anything in the data side. So you get 0 bytes copied. Nothing is copied basically, but a point in time is captured. You can go back to, because other snapshot may be aligned with that. Other disks might have some kind of data associated with. So here is 1 gig out of 10 gig that are changed. You can see the MB size that changed. So only changes are being captured, not the full size again, right? So changes, incremental changes, very, very minimal with respect to what happens in the backend. All the VPC infrastructure with respect to the networking configurations, all of that, for this particular purposes, we put in the application so we configure all of that details here. So VPC configurations are all captured as well. So all of the intricate details about the VPC networks are automatically captured by Appranix. So you don't have to worry about what those infrastructures are. My refresh is taking a bit of time, so I'm going to just quickly refresh all of that. While refreshing, we can talk about specific ones. So you can see the VPC network configurations and the backend of operations and the cloud DNS that takes care of DNS switching. So this particular page is important because we are going to on the fly switch the DNS from the central region over to the East Coast region of the Google Cloud. So you will watch that particular IP automatically changed using a script here. So OpenEMR is the application that has an elastic IP associated with this particular one. And then you have the firewall rules, and these talk about all the routes for the applications as well. So here, Appranix is managing your resilience. So if you think about Appranix, so if you think about how you connect with your cloud infrastructure, you simply start with the add cloud connection, select the provider. In this particular case, you can do a role-based access or the provider key, upload your JSON, single one, and that's it. You don't have to worry about other services. You can add other additional services, Cloud SQL, and so on. And if you are using containers, you come through container resilience part. So with that, what happens is that when you add the cloud connection, it automatically discovers the cloud. And in this particular case, all the infrastructure, global infrastructure is automatically discovered. You can see about as many number of configurations, all of that is automatically pulled directly using native capabilities of the Google Cloud platforms. Once you do that, you can create a cloud assembly by picking kind of roughly putting a box around it. We call it as a cloud assembly, which is basically you pick a policy, you put a test assembly here, assembly, and you simply pick the instances that you want to select the region. In this particular case, it's running in the central one, and you can pretty much select all the resources that you want. In this particular case, only instances are shown, and the Cloud SQL is shown. That way, you are not showing all the networking, none of that complications involved. You simply pick and put a box around it. So for the purpose of demo, I already created one. In this particular case, it's going to be the open EMR assembly. So when you click like the 6 instances that compute instances that I showed here, 6 instances that you pick to create an assembly, it automatically assembles about 49 resources around that 6 instances. That's what I call it. When you go to a typical legacy backup system, you are protecting those 6 virtual machines. But what happens to those 49 resources that are supposed to be captured along with those virtual machines, right? Firewall rules. There are 26 different rules that correspond to those simple 6 VMs that appear as innocent, right, so to speak. But in the backend, you have all the complexity that is associated with the entire application environment, right? All the subnets that you will have to worry about when you bring that application back. All of that needs to be captured. And then you can simply put the policy. So in this particular case, I have an hourly policy that's backing up every hourly with 2 copies as retention copies, and the weekly policy and the daily policy as well. If you need more policies, pretty much create more, and I put a 30 minutes policy, right? Policy, and you can select hourly and then go into load more. You can say 30 minutes or 15 minutes. Again, be careful in terms of choosing this, because you are taking frequent snapshots to capture those ever-changing application data. Then you can pretty much control the number of retention copies that you want to have, both on the primary region side as well as the secondary region that you wanted to keep the copy on. And you can activate the policy immediately at a particular specific time as well. So you can specify time, and you can specify whatever that start time. So typical mechanism in terms of having a very flexible policy-oriented approach to managing your copies of your environment. So in this particular case, all of that is captured. Then everything will fall into something called a timeline. This is what we talk about, an application environment time machine, where entire application environment is captured over a period of time. So today, again, we captured a few, then you can go back in time 7 days ago. Of course, depending on the retention, the system will automatically remove all the snapshot. That way, you pretty much optimize your storage consumption or your cloud consumption. So most of the cloud wastage happens because of storage, because people create all kinds of snapshots and then leave them as dangling snapshots all over the global infrastructure. It's really painful to see. And moreover, when you try to go and delete, nobody has the guts to go and delete them, because nobody knows exactly which particular snapshot belongs to which particular application, and nobody has the maybe time related, or maybe they are afraid of deleting the data, right? So it's better to put a policy around and then let the system manage itself. So what we are going to do is to bring down this particular application. So OpenEMR is running great. I'm going to just kill this application just to show that what happens when you kill this application. And at this particular point in time, I can see, refresh it. Those application infrastructure is getting killed from a virtual machine perspective. We'll come back to this particular console where we will switch the DNS over to the new region. So here, OpenEMR, the browser will take a little bit of time. You can see here it's connecting. So it will try a few seconds and give up, because it's just a browser interface here. So it's not working from an application perspective. So application is pretty much down, right? If not click, nothing is working here. So what we will do, we'll go over to the resiliency solution that was supposedly promised by Apprenix, right? So there, I click a particular point in time. I want to go back to 12 p.m. Eastern. So I'm going to just go to that particular point in time, and you can see there are total resources that changed from that particular assembly alone. I have this many instances with VPC networks, all of that. You can see all the logs, so audit logs are properly captured, so you can pretty much cut and paste and send it to for compliance reasons. But here, I'm going to just recover this particular one. So open EMR is gone, and I'm going to recover it. Test open EMR again. So I'm going to pick another region. So in this particular case, I'm going to put it on the East Coast, and I'm going to select the entire assembly, right, the entire environment, or you can actually pick and select a particular set of resources as well. And if you want to fiddle around with specific instances that you want to recover, then we'll pull all the other ones appropriately. For the purpose of demo, let's do the entire assembly. So hit this point. So 2 clicks, we are here, and then I simply type in recover, because now you are recovering, which means that you are utilizing cloud resources on the other region. So hit the recovery, and that's it, right? If you look at the recovery details, the recovery resources will come up, all the firewall rules, all that. We are not talking about the traditional, VM recovery, the file system recovery, all of that will come up anyway. But you'll have to worry about how to bring the entire environment back from that particular point in time, right? So another tricky thing is that now you're in the cloud. It's not a traditional data center, which means that you will have to really think about infrastructure as code. Infrastructure as code could be CloudFormation, it could be Terraform if you are staying kind of a cloud neutral, but at the end of the day, the closer you are to the native components of the cloud, you have better guarantee in terms of recovering that application, which means a better guarantee for the resiliency, right? So in this particular case, we'll have to write the deployment manager. So how many times you'll have to think about deployment manager, which is basically an entire environment infrastructure as code that needs to be written and configured using a particular point in time, right? At a particular point in time, you will have to figure out what are the variables, what are the attributes for that particular environment, and then make sure that the snapshots associated with that particular point in time is connected with that environment as well. That was a previous recovery that I did. So we named it as a test open EMR. So if you click that particular test open EMR, the amount of code that gets written is this much, which means that if you look at the entire code here, for the purpose of that, we'll just download it here to check what that component is. Let's look at that. So the entire expanded configuration, this is the amount of code that was automatically written by Apprenix at that particular point in time, on the fly with that click, right? You can see the dependency depends on somewhere based on what is specified by Google. There's the right mechanism to code, which means that when the environment scales up for thousands and thousands of the instances, you will have to manage perhaps thousands and thousands of lines of this code structured in such a way that it can come up, because now you're giving the responsibility for Google to bring the entire application environment up, which means that you need to know how to, in the CloudFormation days, you'll have to really think about the nested stacks. Multiple nesting needs to happen to make sure you work around with the quota limitation and the scalability in terms of bringing up the entire application environment, right? The one, that picture that I showed you in terms of really looking at bringing up the entire environment up. You need to bring up the entire components of all these connections, these little dots over here, are all the connections that you will have to bring back on, because applications might be connecting through these entry points or exit ports rather. So you will have to make sure all of that brought up properly, right? So guess what? The deployment is complete. From our side, the recovery completed. So what we'll have to do is to switch the DNS. So we wrote a little script to kind of switch over. So I'm going to just push the button to change this DNS. We give you this script, you can configure it automatically, and we'll actually will make it much simpler in terms of firing it directly from the UI as well. On the AWS side, we already have the capability. On the Google side, we'll give you the flexibility, but we'll also make it easier for you to bring up. So the application is switching over. So you can see the old ones that are running on the central side, they are all down. So the application itself is down, right? And the east set of virtual machines, all of that are brought up properly. So all of the operations part, this is a lifecycle that's getting managed from a snapshot perspective. All the snapshots, all the VPC network configurations are changed. The routes are brought up as well. So all the network routes corresponding to a particular set of instances are brought up. And all the configurations with respect to firewall rules are also automatically brought up as well, right? So all of that is taken care of from bringing up an entire application environment, right? So if you think about bringing back, it's pending in terms of refreshing that DNS. So from a DNS perspective, let's look at this is 148, ending 148. So let's refresh it. That changes over to pointing to the East Coast region of the cloud instance. That's an entry point. Just all we need is an entry point for the application. That entry point of the application IP will be changed on the cloud DNS side. So now the application is now pointing to the East Coast infrastructure as opposed to the West Coast, and you need to have all the patient information coming up as well. So it's pointing to the West Coast now, and cloud DNS, needs to kind of propagate the IP appropriately across. And guess what? Waiting for the application to come up. It's almost there. Hold on, and it is up. Right, the application is back up with the same application data that we captured. So again, from a configuration perspective, all the East Coast ones are down. The central ones are down. The East Coast ones are running here, right? All the East Coast ones, and then all the security group, the front end is maintained. We simply switched the DNS to point to the East Coast. So the OpenEMR application is back. Let's assume that this is great. Now what we are going to do is to kill this environment because we tested. So we are going to just kill it. Again, all we have to do is to reset and delete all the resources because we brought a bunch of instances, all the networking, the entire application environment came back. And now we have to make sure that those are properly deleted as well. So this will be automatically deleted. You can again retain all the logs. If there was a situation where you will have to show what really happened with respect to the test recoveries. You have the complaints logs that you could bring back. So all the delete will happen. And on the deployment manager side, you'll see the deletion happening in the reverse order in which it was created. So you'll have to go back from the bottom to the top to delete all the resources that were created. So you'll go back to what it was, except the data that was stored in the second region, because you needed to have the data to bring back the data and the application stack right after that. So that's the overall capability. You can do that right from the Google platform. It's a service that you can subscribe, and it is very easy to use. Again, from a cost perspective, it's again, I don't want to emphasize too much of that because it's 1/10 of the cost, because we are leveraging pretty much all the capabilities of the Google Cloud, incremental snapshots, all of that, right? the return on investment is huge. So let me stop here. Mike is looking at me in terms of time. Looks like there are a few questions. Yeah, there was one question. Is there a way migrate existing backup to this tool? Unfortunately, no, an existing backup, you might have stored all the backup and everything in your proprietary backup environment. We recommend that you trigger the environment using Appranix, and then as you catch up, you could start with an hourly backup, so you can once you manage that hourly backups are running great, and delete the hourly backup from the old system, and then you go to the probably daily ones, right? You can pretty much delete the daily ones after that. And then slowly, we would recommend kind of a slow migration over, because backup data is critical, right? You don't want to lose it. And we recommend a kind of a slower approach, because we cannot, it's a proprietary data that's stored using proprietary backup manager data, so we cannot do much. But you can pretty much move the hourly, daily, weekly, and as well as monthly. You don't have to wait for 1 year to kind of roll over that yearly. But everything else, slowly you could simply move over and then slowly remove the old backup system. So you can keep, let's say, if it is a 5-year data, yearly data, you can keep it for some time, and then everything else could move over to Appranix in no time. So that's a great question, by the way, a good one. Any other question? The questions come up in terms of Mike is pointing out another question: who holds the keys and permission? Customer holds the keys and permission. We don't take any of these permissions. So even if you are encrypting your data, which is a recommended best practice by the cloud provider, those encrypted keys are stored within your own account key management system within the cloud provider, right? We get the reference of it so that we can bring back, and even you can have 2 different keys, one for your production environment encryption data and your recovery environment. When we recover, we make sure that the recovery keys are properly brought up as well. So nothing moves. We only take a read-only permission to get the configuration of the virtual machines, configuration of the networking, and way to control and take the snapshots. That's about it with respect to SaaS itself. The entire solution runs on Google anyway, so it's all completely built into a huge resilient global infrastructure provided by Google, thanks to them. So yes, the regions come down once in a while. Part of the region is very similar to other cloud providers. They have all gone through, and they will continue to go through. So you will have to expect the infrastructure will go down at any point in time. But your applications need to live through that disruption, right? It could go down even for the maintenance purposes. Cloud providers need to maintain all the virtual machines and the backend hypervisors updated all the time. How would you do that, right? You will have to take down and then update the patches and bring them back again. So how do you survive those situations? All of that need to be brought up as well. So what happens when the Google account itself is hijacked? That's why we recommend that provide this second region component in a second account, completely different project altogether. That way, it's easier to recover as well, because the VPCs are different. The subnets will be managed automatically and brought up very similar to the IP. So all of that will be automatically brought up as well. So it's better that it happens in another. The resiliency happens quarterly, half yearly or yearly in real time. Yes, you could actually trigger. In fact, all the UI that you see here can be triggered using API as well. So you could actually put in your DevOps pipeline, if you will, right? When you do the triggering, you could actually trigger from a Slack environment. It's all connected through API, and you could pretty much automate it, right? You could say every half yearly, bring up this particular point in time and bring back and test it, make sure that application runs, and give me a report. Perfectly, totally fine, right? Since it's provided as a service, we actually make sure that we provide you the reports every day morning. You can trigger a report. You will get the report how many are protected. all of that is completely automated. So it's not like you buy the backup system and then you'll have to manage it and then you'll have to provide the reports yourself. All of this is completely automated, right? It's a cloud service that's provided. So great question again. Yeah, I think Mike is pointing to what kind of data do we really take from cloud application environments. Again, just the configurations. We do not take your application proprietary data. That all stays within the cloud provider. In this particular case, within Google, we do not touch them. In fact, the best practice is encryption. So you encrypt it, you keep the keys, you rotate the keys as per your organization governance policies. You're free to rotate them anytime. Appranix doesn't work at that level. It works in terms of information that we get is just the configurations. The question is, can we get the recording session after? Absolutely. Mike will send you all the details. So it's captured and kept. And in fact, you can go back to our old webinars. If you type in on Google, Appranix and YouTube, you'll get the entire webinar series that we have been doing on resiliency forever, so to speak. So, Appranix means application resiliency, particularly cloud application resiliency is day in, day out is what we do. And we happen to provide a backup at 1/10 of the cost using all the cloud native capabilities. So absolutely recorded and will be given to you perhaps tomorrow. Mike, I'm looking at Mike. I think it will be available tomorrow. All right, so we are hitting at the top of the hour. We don't want to take more of your time, not even 1 minute of yours. So we give back and really thank you very much for listening to us. Really appreciate it. So one more question popping up here. Just quickly, what are all the companies following the companies following the resilience? I mean, if you look at AWS has been pushing the resiliency as part of the well architecture. So one of the pillars of the resiliency for their well architecture is resiliency, right? And from our side, you have seen a bunch of these in our own examples here. It's a huge one here. I don't want to name the name under NDA, but you'll get an idea. And some of these companies, they're all doing the resiliency now. It's not just the backup. Backup is infrastructure. Yes, we have to do the backup, no question. You have to take care of the copies, manage the copies, but not just the VMs, not the database, not the file system, entire application environment. That's what really matters at the end of the day. How do you bring up your application back? And that is called cloud application resilience. And if you happen to hit the backup requirements, perfect from a compliance perspective, ransomware recovery perspective, all perfect. Give me at the lowest point possible, right, to optimize the cloud spend. So we take care of that. So with that, we really thank you, really appreciate your time. Have a great day from here. Thank you.